318 Zulu. Eastern Ukraine. Latitude 48.6 north, longitude 37.9 east. Low cloud ceiling at 400 meters. Temperature -4 Celsius. Wind from the northeast at 7 knots. Industrial lights glow faintly through freezing fog, outlining a complex of rectangular buildings and rail spurs, officially listed as a civilian electronics plant. Unofficially, it is one of Russia's most productive UAV assembly facilities, operating 20 hours a day. Inside the perimeter, early warning radars rotate at 4 revolutions per minute. Short-range air defense systems sit idle, barrels covered against frost. Power draw is steady. Network traffic normal. From the Russian command perspective, the site is secure. It sits 90 kilometers behind the front line, outside tube artillery range and under the umbrella of layered surface-to-air missile batteries positioned to the east. At 3:21, a shift change occurs. Cargo trucks stop arriving. Conveyor belts slow. Inside the production hall, composite airframes for Shahid-type attack drones hang from steel racks, mid-assembly. Guidance modules wait in sealed crates. Operators assume the night will pass without incident. On a regional operations map, the area is marked green. No alerts from counter-battery radars. No signals intelligence spikes. No drone incursions reported within the last 72 hours. Russian planners believe Ukrainian strike capacity is focused elsewhere. Bridges, fuel depots, frontline logistics hubs. What they do not see is that the factory has already been mapped down to the meter. Thermal signatures catalogued. Power substations indexed. Network nodes logged. For the Ukrainian side, this is not a target of opportunity. It is a linchpin. At 3:24 Zulu, multiple Ukrainian systems synchronize clocks. GPS time signals align within microseconds. A quiet countdown begins across hundreds of kilometers. The factory continues to hum, unaware that in less than 20 minutes, it will no longer exist as a production node. 3:26 Zulu. 200 kilometers west, in dispersed launch zones hidden among tree lines and abandoned farms, Ukrainian operators power up long-range one-way attack drones. Each unit weighs under 50 kilograms. Unit cost, a fraction of a single surface-to-air missile interceptor. Flight profiles are preloaded, terrain following at 60 meters altitude, cruising speed 130 kilometers per hour. Simultaneously, electronic warfare teams activate passive signals intelligence receivers, listening rather than transmitting. Russian air search radars sweep high and miss low. Their detection thresholds are tuned for fast jets and cruise missiles, not small composite frames skimming frozen fields. At 3:29, the first wave launches. 12 drones climb to 120 meters, then descend to nap-of-the-earth altitude. Their engines produce less acoustic signature than a light motorcycle. Infrared output is masked by cold air and engine shrouds. From Russian screens, nothing changes. At 3:31, a second layer activates, decoy drones broadcasting exaggerated radar cross-sections. They approach from the southeast at higher altitude, intentionally visible. Russian Air Defense Command posts flag them as probable reconnaissance assets. Fire authorization is delayed. Ammunition is conserved. Unknown to the defenders, these decoys are bait. The real strike package is approaching from multiple azimuths, timed to arrive within a 90-second window. Ukrainian planners anticipate radar queuing delays and human reaction lag measured in tens of seconds. Inside the factory, power consumption spikes briefly as night heating cycles engage. The substation compensates. No alarms trigger. Network traffic remains steady, routing production data through civilian infrastructure. At 03:35 Zulu, Ukrainian operators observe Russian radar emissions shifting frequencies, search patterns adjusting toward the decoys. The defenders are looking in the wrong direction. 3:37 Zulu. Strike drones past the 40-kilometer mark. Altitude fluctuates between 45 and 70 meters as they follow riverbeds, rail embankments, and frozen access roads. Spacing is deliberate, 600 meters between airframes to reduce visual clustering and radar correlation. Speed adjusts dynamically. Lead elements slow to 110 km per hour, allowing trailing drones to synchronize arrival. In the Ukrainian command node, operators monitor telemetry streams, altitude, heading, engine RPM. Displayed in monochrome to reduce eye fatigue. At 3:40, Russian short-range air defense radars finally register intermittent contacts, flickers at the edge of detection. The tracks are inconsistent, appearing and vanishing as terrain masks returns. Controllers debate false positives versus birds, versus debris. At 3 hours 41 minutes and 30 seconds, one drone crosses directly over a heated water pipeline. Thermal contrast spikes. A Russian operator marks it. Cueing is sent to a nearby anti-aircraft gun system. Barrel elevation adjusts. The gun slews left. But the drone is not alone. 30 seconds later, 3 more appear on different bearings. Fire control hesitates, too many tracks, not enough clarity. At 3:43, Ukrainian decoys at altitude trigger a missile launch. A surface-to-air missile streaks upward, costing more than the entire attacking drone swarm combined. The decoy disintegrates. Mission complete. Below, the strike drones accelerate. Distance to target, 8 kilometers. Operators switch to terminal guidance. Camera feeds activate, showing factory roofs rimmed with ice and exhaust vents glowing faintly. The drones split into sub-elements. 2 line up on the main assembly hall. 1 angles toward the power substation. Another drops to 20 meters, aligning with a ventilation intake, an access point previously mapped via satellite and human intelligence. First contact is imminent. Russian defenses are now awake, but awake is not prepared. 3:44 Zulu. Fog thickens unexpectedly, reducing visual range to under 300 meters. For drones, this is neutral. For human operators relying on optical confirmation, it adds seconds of uncertainty. Electronic warfare activates. Russian GPS jammers flood the area with noise. Several drones lose satellite lock. In response, inertial navigation systems take over, drifting less than 2 meters per kilometer, within acceptable error margins. At 3:45, one drone experiences data link interference. Video freezes. Autonomous mode engages. It continues on last known vector, altitude 55 meters, speed 125 kilometers per hour. There is no recall option. Inside the factory, a backup generator test begins, routine, unconnected, but fatefully timed. Power briefly shifts loads. Exterior lights flicker. For Ukrainian sensors, the flicker confirms internal electrical topology. Russian anti-aircraft guns open fire. Tracer arcs slice through fog. Ammunition expenditure increases rapidly. Gunners track ghosts, radar cues without solid visual lock. One drone is hit. It tumbles, impacting a storage shed outside the main perimeter. Damage negligible. At 3 hours 46 minutes and 20 seconds, Ukrainian operators face a decision point. One drone is off course by 15 meters, heading toward a low-value warehouse. Retargeting risks exposure of command links. They choose silence. The drone continues. Friction compounds. Weather, jamming, human hesitation, all compress timelines. Yet the swarm remains intact. 17 drones are within 90 seconds of impact. Russian command attempts to escalate, requesting authorization for wider air defense engagement. Approval is pending. The factory, still operational, is seconds away from structural failure. The margin for defense has collapsed into noise, fog, and delayed commands. 3:47 Zulu. Ukrainian planners initiate the saturation phase. Remaining drones alter altitude in staggered profiles, some climbing to 90 meters, others dropping below 30. This vertical dispersion overwhelms fire control algorithms calibrated for uniform threats. Decoys reappear on Russian screens, broadcasting false telemetry and mimicking larger platforms. Radar displays bloom with overlapping tracks. Prioritization fails. Operators engage the nearest targets, not the most dangerous. At 03:48, the first strike drone impacts the substation. The warhead detonates inside the transformer yard. Oil ignites. Power drops across the complex. Interior lights die. Conveyor belts halt mid-cycle. Seconds later, a second drone slams into the assembly hall roof at a 40-degree angle, penetrating steel sheeting before detonating. Composite airframes stored inside amplify the blast. Fire spreads laterally, fed by resins and fuel cells. Russian air defense systems continue firing, now effectively blind. Without power, sensor fusion degrades. Manual control takes over, slower and less precise. At 3:49, 3 drones arrive simultaneously from different bearings. One targets a communications mast, severing external links. Another hits a loading bay stacked with packaged attack drones awaiting shipment. Secondary explosions ripple through the structure. The swarm is no longer a formation, it is an event. Each impact reduces defensive capacity, making the next more certain. Cost-exchange ratios spiral. Thousands of dollars erase millions in infrastructure. By 3:50 Zulu, fires are uncontrolled. Russian defenders retreat from exposed positions. The factory is no longer producing. It is collapsing. 3:51 Zulu. One final drone remains. It has been flying low, masked by buildings and smoke. Its target is the central server room, housing production data, firmware libraries, and network routing hardware. It climbs briefly to 60 meters to clear a collapsed crane, then dives. At 3 hours 51 minutes and 22 seconds, it passes through a shattered window and detonates inside the control core. The blast is contained, directional. Racks fold inward. Hard drives shatter. Cooling systems rupture, flooding the room before igniting. Digital infrastructure ceases instantly. Outside, structural failure accelerates. Roof trusses sag, then give way. Flames punch upward, visible from 20 kilometers away. Shockwaves shatter remaining glass. Russian command finally authorizes full engagement, but there is nothing left to engage. No airborne contacts. Only fires, smoke, and dead sensors. At 3:53, secondary explosions mark the destruction of stored guidance units and fuel. The firestorm peaks. Thermal signatures overwhelm any remaining detection equipment. From a strategic perspective, this is the kill shot, not the physical collapse, but the digital one. Production data is gone. Tooling configurations erased. Supplier integration severed. The factory will not resume operations in weeks or months. Reconstitution requires time, logistics, and safety, none available under continued threat. At 3:55 Zulu, Ukrainian systems power down. Operators log results, then disperse. There is no celebration. The operation is complete. By 4 o'clock Zulu, satellite imagery confirms total loss. What was once a drone factory is now a burning industrial scar. Estimated rebuild cost, tens of millions. Estimated Ukrainian expenditure, a fraction of that. More significant is the ripple effect. Without this node, Russian UAV networks experience immediate shortages. Frontline units report reduced reconnaissance coverage within 72 hours. Strike drone availability drops. Mission tempo slows. The lesson is not about firepower, but about systems. Cheap, distributed one-way attack drones exploited gaps in expensive, centralized defenses. Electronic warfare, fog, and human delay multiplied effects. This was not a battle. It was a demonstration. A single night collapsed weeks of production and months of planning. No front line shifted, yet operational balance changed. Modern warfare no longer requires dominance everywhere, only precision at the right node. Factories, servers, substations are now frontline assets. Protection is harder than production. As conflicts evolve, questions remain. Can traditional air defense architectures adapt fast enough? Can centralized manufacturing survive in a world of persistent surveillance and low-cost strike systems? Or will future wars be decided not by tanks and ships, but by the quiet destruction of networks before they ever reach the battlefield?